This module we will learn about measurement of variability. Now, variability is nothing but the variations of various observations within a sample. Now, one of the easiest way to measure variability is range. Range is nothing but the highest and the lowest value, the difference of it. Let's say in a score, student scored, the lowest score was 3 and the highest score was 7. So range will be from 3 to 7. Another way and statistical way would be measurement of variance, deviation score and standard deviation. We will go into detail of calculation of each of the following. Now everything starts with the calculation of deviation score. What is deviation score? Let's see with an example. Deviation score is nothing but the difference between the mean of the sample and individual observation. Let's say this is a table which shows 5 students who have appeared for a test, and the first column actually shows the score. Now the first step is actually calculation of the mean. So if we add all this, it comes to 35. So total score is 35, number of students is 5. So the mean score of this particular observations would be 7. To calculate the deviation score, we minus 7 from each of these observations. So 8 minus 7 is 1, 6 minus 7 is minus 1. So variance score can have plus or minus. From this variance, this is deviation score. From this deviation score, we try to derive the variance. Variance is nothing but if we square the entire thing and add it up. So let's move to the next. So variance of a population, if we have to calculate, it's the deviation divided by the number of samples. If we have to calculate the variance of a sample, then the formula changes, and in the denominator n changes to n minus 1. Now why this change happens is beyond the scope of current of this particular module, but you have to remember this particular important fact, that if you are calculating the variance of a population, the denominator is only n. If you are calculating the variance of a sample, the denominator is n minus 1. So from this variance, we can easily calculate standard deviation. Standard deviation is nothing but, because this is a square root, we just have to do the square root of the entire thing. So standard deviation is nothing but square root of variance. So just to reiterate, first we'll calculate the deviant score. From deviant score or deviation score, we will calculate the variance, and from variance, if we square root it, we will get the standard deviation. Now what does this mean? I mean, understanding variability, these two curves, if we just analyze on central tendency is nothing but mean median mode for our example. So both will have the same mean median mode. But if you see in the first graph, which is B, the values are more cluttered together, and so the variation is less, right? And in the second graph, the values are little more scattered, so variation is more. And in both the graphs, if you see, the range is also same. So even if the range is same, the central tendency, that is mean median mode, is same, still because of the dispersion of the values of individual observations, we can have different standard deviation. Now I'll take a little more time to explain you and make sure that you understand standard deviation. Now what is basically, we talk in terms of 1 standard deviation, 2 standard deviation, 3 standard deviation. This is the graph which will make it much more clear. This is a binomial distribution curve. This is the mean. This value is the mean. Now 1 standard deviation is 68% of the observations. So standard deviation, this value will say mu minus 1 standard deviation. Mu is mean. This will show mu plus 1 standard deviation. So 68% of the observation is with 1 standard deviation. So this value mu minus 2 is 2 standard deviation below the mean, 2 standard deviation above the mean. So this will have 95% of the observations. And if you talk about 3 standard deviation, mu minus 3 standard deviation, mu plus 3 standard deviation, this will have 99.7%. Now, in fact, a lot of questions has been asked about the exact percentage. So I think you should remember it, that one standard deviation, 68.27% of the observations remains in that. Two standard deviation, 95.45% of the observation is there. Three standard deviation, 99.73 standard deviation. At this stage also, I'm sure that most of you would have a little confusion about understanding standard deviation. So I'll take another example to explain you standard deviation. Now, let's say mean of a fasting blood sugar level of all the residents of New York is 108 with a standard deviation of 6. What does this mean? This means that one standard deviation, if we see, it's 6. Two standard deviation, because we have seen standard deviation is 6. So two standard deviation is 2 into 6, 12. Three standard deviation is 3 into 6, 18. Now, so we understand that 68% of the people is expected to have fasting blood sugar between 108 and 114. This 108 and 114 has been calculated. 108 minus 6, 108 plus 6. So 95% of the people is expected to have fasting blood sugar between 96 and 120, and 99% of the people is expected to have fasting blood sugar between 90 to 126. So here we use the concept of standard deviation to define that if a reading, so suppose a person comes with a blood sugar of 135, fasting blood sugar, so we can be 99% sure that his fasting blood sugar is not normal, because 99% of the normal people will have fasting blood sugar between 19 to 126. Now, let's look another example. Suppose in a physics test, you get that students scored with a mean of 50 and a standard deviation of 5, or a student with a mean of 50 and a standard deviation of 18. What does this mean? Well, in the first test, mean of 50 and a standard deviation of 5 means that it was an easy test, because out of 100 students scored 80 on an average, and also most of the students, the standard deviation is very less, so the scores of the individual students are cluttered. In the next test, the mean is 50, which means it was a tough test. Out of 100, 50 was the average score, and the deviation was also high. So good students scored very well and bad students scored very less. If we have to graphically represent, we can get something like this. So here the mean is 80 and values are cluttered together. Here the mean is 50 and the values are more scattered. What does this mean? Mean of 50 and a standard deviation of 0. Well, this means that there is no standard deviation, which means each and every student scored 80. That's it. So I hope you understand the concept of standard deviation by now. If you're not sure, just go behind, see this lecture again, and I'm sure that by the end of once or twice you'll be able to understand the concept of standard deviation. The entire analysis in biostats is based around standard deviation. So this is one concept you cannot forgo. The next module is on Z-scores. Now, Z-scores is also a measurement of variability. If we see Z-scores, it is the location of any element in a normal distribution curve expressed in how many standard deviation above or below it lies from the mean. Let me give you the formula. So Z-score would be x is the observation minus mu divided by the standard deviation. Let's see an example. In the previous example, we saw that fasting blood sugar in a New York population is 108 with a standard deviation of 6. So what is the Z-score of 116? So if a person comes with a fasting blood sugar of 116, what will be his Z-score? Let's start calculating. So Z-score is 116 minus 108, which is the mean, divided by 6, which is the standard deviation. So it comes to 8 by 6, which comes to plus 1.5. Plus denotes that this value is above the mean. So this means that fasting blood sugar of 116 is 1.5 standard deviations above the mean, or the Z-score is plus 1.5 for a value of 116. Let's move forward and understand this particular concepts a little more. So this is a typical table of a Z-score. Now, Z-score is useful when you have a predetermined mean and a predetermined, pre-measured standard deviation, and any new value you want to see that where it fits in the entire range. We will see more by examples. So this is the Z-score table. It's a huge table. All the statistics books will have it. So I'm just trying to tell you that this is the plus 1.5 value, that is 0.068. Let's understand what this 0.0668. Let's for now focus on this value 1.5, whose Z value or the area beyond Z is 0.0668. So we saw that the fasting blood sugar of 116 has a Z-score of plus 1.5. Now this means fasting blood sugar of 100 will have a Z-score of minus 1.5. So from Z table, 1.5 corresponds to 0.068 or 6.8% area beyond the curve. So if we have to graphically represent, this is our Z value curve. This is the center part, 0, where this is equal to the mean. If we see fasting blood sugar, Z score of 1.5, so this is plus 1.5. And if we see, this area is 6.8%. And if we see fasting blood sugar of 100, Z score of minus 1.5, this area is 6.8. So if you see, so if Z score of 116 actually means that only 6.8% of the values will be more than this. Rest all the values will be less than this. So this is very important in terms of various statistical analysis. We will look into certain examples later on. But this is what you should understand about that. If you calculate the Z score, you can say that what is the percentage of observations which is above it, what is the percentage of observations which is below it.